Good morning. We're going to talk about projectile motion today. There will be two parts for this video. The first part will involve the theory, which will be a fairly short video, and then we'll be doing one example. Okay. So projectile motion is essentially also called ballistic. It's the physics of throwing an object which once thrown is just subjected to gravity. Okay, so if we have a flat ground right here, an object is going to be thrown from point A, and it's going to be subjected to gravity. I'm going to draw the gravity vector right here. Okay, I'm drawing it up and down. The magnitude of the gravity vector will be 9.8 meters per second square if you use meters, and it will be equal to 32 feet per second square if you're going to measure things in feet, inches, miles, etc., etc. Okay? So once the object is thrown, essentially it's going to describe a parabola. And the only thing that will influence this parabola, besides, of course, gravity, will be the initial velocity vector. So it's going to be the initial velocity vector, which will have a certain velocity measured either in meters per second or in feet per second, and an angle alpha. Okay. So it is not the purpose of this class or this video to derive those formulas. I'm going to make another formula where another video where those formulas are derived, but here I'm just going to give you the kinematic equations for this. So the projectile is initially thrown with this angle, with this velocity, and after a certain amount of time t, we're going to be at the point P right here. Okay. At the end, we're going to land and be at the point B right here. So what we want to know here is where this point P is. We're going to measure its position in relation to the point A, which we're going to consider to be our origin. Okay. So the point P is going to have two coordinates, the coordinate x of t and the coordinate y of t. Okay. We can also think about it as the vector AP, where those two components will be the components of that vector. But we can also think of it as a system of equation, a point P, which has four coordinates x of t and y of t. Okay. I'm not going to say x and y because the point P is going to change, its position is going to change as t, the time varies, right? So x of t, y of t. So x of t is going to be equal to v sub 0, or v naught, or v initial, which is the magnitude of the initial velocity vector, times the cosine of the angle alpha, again this being the alpha that I'm talking about, times t. Since the point A is the origin of my system of coordinates here, that's all we're going to have. Okay. As for the point, the y coordinate, it's going to be negative half of g t squared, g being either this or this, and t being the time measured in seconds. Okay, plus v sub 0 sine alpha t. Same thing, v sub 0 is the magnitude of the initial velocity vector, alpha is the launch angle, and t is the time. Okay, and then that's pretty much it, again, because the point A is considered the origin of our system. Okay, so that's really all there is to this. Those are the kinematic equations. Okay, kinematic equations. If you want, you can also consider the velocity equations, which will be the velocity in the x direction and the velocity in the y direction. Both of them are also parametric equations, the parameter being t. Okay, so those will be the velocity equations. Okay. So the velocity in the x direction, when we deal with ballistic motion or projectile motion, is going to be a constant. It's always just going to be v sub 0 cosine alpha. And in the y direction, it's going to be negative gt plus v sub 0 sine alpha. Okay. So based on those two sets of equations right here, you should be able to calculate anything that you want. Okay. The difficulty thereafter will be in manipulating those equations algebraically, which I'm going to show you in the second part of this tutorial videos.